Hi. In this lecture, we're going to look at our first model of pure effects. This is going to be a very short lecture, but I just want to get the idea of pure effects out there and introduce really what I think is an interesting point. And that is namely that when we think about these sort of contagion phenomena that happen through things like pure effects, that sometimes the tail wags the dog. What do I mean by that? What I mean is that sometimes the people at the end of the distribution, the extremists, are the ones that really drive what happens. And as a result, that means it's going to be incredibly difficult to predict what's going to go on. So that's the basic lesson of this model, that the tail is going to wag the dog. So this model is developed by a guy named Mark Granovetter, who's a sociologist at Stanford University, and it's really fun. It's one of my favorite models just because of its simplicity and elegance. So before I present the model, I want to, again, get to this point about predictability. So recently we've had some events. We've had uprisings in Libya and in Egypt, and these caught everybody off guard. There weren't experts lined up saying Egypt's about to topple, Libya's about to topple. In fact, no one predicted it at all. You know, you don't have to go far back in time to the Orange Revolution and see that nobody predicted that either. When the Ukraine suddenly had this giant uprising, this political uprising, that too was unexpected. Ditto for the Berlin Wall. You didn't have anybody seeing this coming. Now, it's easy to say, oh my gosh, these experts aren't really experts. And there's a sense in which, well, we can be critical of how smart the talking heads on TV are, but it wasn't just the talking heads. It was no one anywhere saw this stuff coming. So we're going to use Granovetter's model to explain, why that's the case, why it can be very, very hard to anticipate sort of a whole bunch of people moving or joining some cause. All right, so here's the model. Very simple, super simple. So there's n individuals, so there's n people. Each person has a threshold. This threshold is like how many other people would have to join the movement in order for them to join the movement. So if your threshold is 0, if your threshold is absolute 0, that means nobody else has to join. You're going to, grab your stick and run out there in the streets, right? If your threshold's 50, then you need to see 50 people out there before you join in the sort of collective movement. So each person has a different sort of threshold for whether they're going to sort of join in and participate in some collective activity. So that's the model. What we want to do is we want to analyze how that outcome varies depending on these distribution of these thresholds, right? What causes a collective action to occur, collective movement to occur, and when doesn't it? Okay, to sort of make this a little more fun and a little less heavy, instead of thinking about people rising up and overthrowing some dictator, let's think about people wearing some silly thing like a purple hat. So suppose you have a group of friends, there's 5 of you, and any one of you at any given moment in time could decide to start wearing a purple hat, and there's a question of do you wear a purple hat? Well, let's suppose here's how it works. We've got 5 people, right? And here's their thresholds. So their thresholds are 0, 1, 2, and 2, and 2. So this person who's got a threshold of 0, you know what? They like how they look in purple. He likes how he looks in purple hats, so he's just going to get one. These 3 people have thresholds of 2. They're really not that keen on purple hats, but if their other 2 friends wear purple hats, then they're going to get one. So let's see what happens. So the person who's got the threshold of 0, well, they buy the hat and they put it on because their threshold was 0. Once they buy the hat, the person who's got a threshold of 1 buys the hat, right? Because one of their friends has the hat, so they think, well, that's fine, I'll wear the hat. Well, once the 2 of them wear the hat, right, then these 3 people down here, these 3 people at a threshold of 2, they buy the hat, and everybody ends up buying the hat, right? So you get this collective purple hat movement within your group of 5 people. Okay, that's example 1. Okay, let's do another example. This time, there's 5 people. 3 of them have thresholds of 1, and 2 of them have thresholds of 2. Well, what happens in this case? That's right, nothing. Nobody ever buys the hat because nobody's got a threshold of 1. This is what I mean by the tail wagging the dog. There's no one who's got that threshold of 0. There's no one who really, really wants to wear the purple hat, so it never takes place. Okay, let's do one more. So in this one, we've got 5 people. And now their thresholds are 0, 1, 2, 3, 4, and 5. So we've got someone at 0 and someone at 4. So 0 through 4 are the thresholds, right? Well, what happens in this case? Well, in this case, the person who's got a threshold of 0 buys the hat, right? Because they want the hat. Once he buys the hat, the person who's got a threshold of 1 buys the hat. Once those 2 have the hat, the person who's got the threshold of 2 buys the hat, right? Once those 3 have the hat, the person with the threshold of 3 buys the hat. And once those 4 have the hat, this last person who really didn't want the purple hat, right, gets the purple hat because all of his friends have it. So you end up with all 5 people having the hat, even though the people really weren't that keen on having purple hats. So what do I mean by they're not that keen? Well, let's compare the last 2 examples in a little bit more detail. Remember the one example where nobody gets the hat, the average value, there was 3 with 1 and 2 with 2. So the average number of people that have to get a hat for someone to get a hat is 1.4. So people are pretty willing to get purple hats, but there's just no one to get it started. In the second case, where you've got 0, 1, 2, 3, and 4, the average value is 2.5, right? And so here you've got people who are really, really willing, I'm saying not very willing to get hats, but what happens is they do get the hats because you've got this person at 0 and this person at 1, so the tail's able to wag the dog. All right, so what do we learn from this? We learn that collective action, collective participation is more likely to happen if, right, there's lower thresholds, if people are really angry, really upset, or really want to wear the purple hat. But we also learn, and this is the surprising part, that it's more likely to happen if there's more variation in the thresholds. If there's more people who sort of at the low end want to wear the hats or participate in the collective action, that sort of can cause the whole system to ripple, can cause a cascading effect in which you get collective action. That's why it can be very difficult to figure out if there's going to be some sort of uprising, because you not only need to know the average level of discontent, right? You need to know the distribution of discontent. You've got to know, are there a handful of people, a group of people who are really willing to sort of rise up? And in addition to knowing that, you've got to know, are those people connected to one another in an interesting way? And that's what we'll start looking at in the next lecture. We're going to push this a little bit further, and we're going to do something called the standing ovation model, which allows us to look at this sort of peer effect phenomena in a little bit more detail. But for now, right, this simple ground pattern model gives us a lot. It tells us if you want to ask, do you see collective action? Yes, it matters how much people are willing to participate, right? How low their thresholds are. But it also matters what that distribution of thresholds are. And if you've got more heterogeneity, more diversity, more people in that tail really willing to riot, you're more likely to get a collective action. Thank you.